Welcome back to the deep dive. Today, we're getting into something that could really shake up how we learn, education.
Yeah, a big one.
Specifically, how artificial intelligence is making waves. We're focusing on these things called Intelligent Tutoring Systems, or ITS.
It's a really exciting space. For ages, the sort of gold standard has been that one-on-one tutor, right?
Yeah.
Someone sitting with you, figuring out exactly what you need.
Personalized attention, yeah. Adapting right there on the spot.
Exactly. Tailored feedback, moving at your pace. We've always known it works incredibly well. The big problem, though?
Cost. Availability.
Both. It's super expensive, and most people just, can't access it. It's not scalable in the traditional sense.
Right. And that's where AI potentially comes in. We've been looking at this source called the Always-On Mentor, how intelligent tutoring systems are personalizing learning support. It lays out this vision.
It really does. The fundamental idea is using AI to try and, replicate that human tutor experience, but in a way that can scale, making that personalized support available to potentially everyone.
Okay, so our mission for this deep dive is to unpack that. What exactly are these ITS? How do they actually work? What benefits could they offer? And importantly, what are the catches, the challenges we need to watch out for?
Sounds like a plan. There's a lot to dig into.
Definitely. So we thought the best way to structure this is like a Q&A based on the source. We've pulled out some key questions. Let me just run through them quickly so you know where we're headed.
Good idea.
Okay, first, what really makes an intelligent tutoring system different from just a basic educational app? The kind that just fires questions at you. Second, can we break down the anatomy? The source talks about different AI models working together. What are they?
Components, yeah.
Third, if one part knows the subject, how does it get to know the student? That personalization piece.
Crucial question.
Fourth, okay, so it knows the subject, knows the student. How does it decide how to teach? What's the teaching strategy part?
The pedagogical side.
Fifth, and how does the student interact with all this? What's that interface layer look like?
Right, the user experience.
Sixth, moving beyond the structure, what are the key things these systems can actually do for a student? The main capabilities.
What's the payoff for the learner?
Seventh, we talked about the human tutor feeling safe and personal. Does an ITS offer anything similar there, that non-judgmental aspect?
Good point.
Eighth, the source mentions democratizing support. What are the big benefits for students if these become widespread?
The societal impact, potentially.
Ninth, what about teachers? How do these systems help them? Are they supposed to replace educators? That's a big fear, isn't it?
Always comes up.
10th, this all sounds pretty amazing, but there must be significant challenges, right? What are the major hurdles in actually building and using these things effectively?
Definitely hurdles.
11th, and what about the limits of AI? What can it do compared to a human tutor? The human stuff.
The empathy gap.
Exactly. 12th, and the big one, ethical concerns. What do we need to be really careful about? Data bias.
Non-negotiables, really.
And finally, 13th. Pulling it all together, what's the big picture vision for ITES in the future of education?
Where is this all heading?
Right. So that's our roadmap. Ready to jump into the first question?
Let's do it.
Okay, question 1. What makes an intelligent tutoring system different from a simple educational app that just asks questions and gives answers?
Right, that's a really important starting point the source makes clear. Think about most standard educational apps. Maybe a language learning app, or a math practice tool.
Yeah, like digital flashcards or multiple choice quizzes.
Sort of. They often follow a very preset path. They ask a question from a bank, you give an answer, it checks if it's right or wrong based on a pre-programmed key.
And maybe gives you a standard explanation if you mess up.
Exactly. It's often quite linear, quite rigid. It doesn't really adapt beyond maybe picking easier or harder questions from the list. It's basically following a script.
Okay, so how does an ITS go beyond that script?
Well, the key difference, according to the source, is that an ITS isn't just one program following a script. It's powered by several interconnected AI models that are working together dynamically.
Interconnected AI models. Okay, doing what?
Their goal isn't just to deliver content and check answers. It's much more ambitious. They're designed to actively simulate the reasoning and the pedagogical strategies of an experienced human tutor.
Simulate. Like trying to think like a teacher.
In a way, yes. Trying to understand why a student might be struggling with a concept, not just that they are struggling, and then adapting its approach, the explanation, The next question, the feedback based on that understanding in real time, it's dynamic, not static.
Okay, that's a fundamental difference then. Not just a quiz machine, but something trying to actually, well, tutor.
That's the core idea. Much more complex under the hood.
Which brings us neatly to question 2. Can you break down that complexity? What's the anatomy of an IICE? The source mentions several AI models. What are they?
Yeah, the source lays out typically 4 key components or models working together. The first one is foundational. The system has to actually know the subject it's teaching. Really know it. This is called the domain model.
The domain model, like it's internal expert on, say, algebra.
Exactly. Sometimes it's even called the expert model. It's essentially a structured knowledge base of that specific subject, algebra, biology, physics, whatever it is. It contains the concepts, the principles, the rules, formulas, common problem-solving procedures.
Of all the facts and figures.
Yes, but critically, it's more than just a list of facts. The source emphasizes that a good domain model also understands the relationships and dependencies between those concepts.
Ah, okay. So it knows you can't really teach someone about quadratic equations if they haven't grasped basic algebraic manipulation first.
Precisely. It knows that understanding division is necessary before tackling percentages, or that certain physics principles build upon others. It maps out the logical structure and prerequisites within the subject. That's crucial for guiding learning effectively.
Got it. So that's the what to teach part, which leads to question 3. The domain model knows the subject. What about understanding the student? How does it personalize?
Right, because knowing the subject is useless if you don't know who you're teaching.
Wow.
This brings us to the second key component, the student model. The source calls this the diagnostician.
The diagnostician. Sounds like it's figuring the student out.
That's exactly its job. This is really the heart of the personalization in an IES. It's constantly working to build and, importantly, update a detailed profile of the individual learner.
Updating how? Based on my answers.
Yes, but it goes much, much deeper than just tracking right versus wrong. The source explains it uses machine learning techniques to analyze your interactions.
What kind of interactions?
Your answer is yes, but also maybe how long you take, where you pause, the specific types of errors you make. From all this, it tries to infer things like...
Like what?
Well, what concepts you seem to have mastered, what you're currently struggling with, and crucially, what specific misconceptions you might hold.
Misconceptions? Like if I always forget to carry the 1 in addition or misuse a specific formula.
Exactly. It tries to pinpoint those recurring patterns of error, the underlying misunderstanding, not just the surface mistake. It also tracks your learning progress over time, your typical pace.
Wow. Okay.
And it can even try to infer your preferred learning style. Does this student seem to respond better to visual explanations like diagrams or textual ones, or maybe interactive examples?
That's getting really granular.
It is. And the source even mentions that some more advanced systems are exploring affective computing.
Affective computing, what's that?
Trying to infer your emotional state. For instance, by analyzing things like your keystroke speed, how long your pauses are, maybe even patterns in your clicking. It might try to guess if you're feeling confused, frustrated, bored, or engaged.
Whoa. Okay, that's potentially powerful, maybe a bit creepy.
It raises questions, for sure. But the goal is to make the tutoring more responsive, just like a human tutor might notice if you're getting discouraged.
Right. Okay, so the system has the domain model, knows the subject, and the student model knows the student, including struggles and maybe even feelings. Question 4. How does it actually decide how to teach? What connects those two?
That's the job of the third core component, the pedagogical model. You can think of this as the tutor or the coach. It's the AI's teaching brain.
The teaching brain, okay.
Its function is to look at the information coming in real time from the student model. Where is this learner right now? What do they know? What are they struggling with? How are they feeling? And combine that with the knowledge from the domain model. What's the next logical concept or skill in this subject to decide on the best course of action?
The optimal pedagogical action, as the source puts it.
Exactly. It's constantly making decisions about how to interact with you at that specific moment to maximize your learning.
What kinds of decisions? Like what?
All sorts. It might decide on the very next problem to give you, making sure it's matched to your current inferred skill level, not too easy, not too hard, hitting that sweet spot for learning.
The zone of proximal development.
Precisely that concept.
Yeah.
It also decides when you might need help. Should it jump in with a hint now or let you struggle a bit longer? And if it does offer a hint, what kind of hint?
Oh, there are different kinds.
Yeah. Should it be a very direct pointer, like check your calculation in step 2? Or maybe a more subtle hint, like offering a simplified version of the problem? Or perhaps asking a guiding question to prompt you to think about it differently.
Like the Socratic method the source mentioned.
Exactly. Engaging you in a dialogue, asking probing questions to help you discover the answer or the principle yourself, rather than just telling you. That promotes deeper understanding and critical thinking.
And it adapts based on my state. Like if it thinks I'm frustrated.
Potentially, yes. If the student model flags frustration, the pedagogical model might decide to, say, adopt a more encouraging tone in its text feedback, or perhaps offer a completely different type of explanation, maybe switching from text to a visual if the first approach wasn't working. It's constantly adjusting its strategy.
That's incredibly dynamic. So we have the expert domain, the diagnostician student, and the coach pedagogical. That leaves question 5. How does the student, me, actually interact with all this complex machinery? What's the fourth component?
Right. All that intelligence needs a way to communicate. That's the user interface, or UI. The source sometimes refers to this as the conversation layer. It's simply the part of the system you actually see and interact with.
The screen, the buttons, the chat window.
Basically, yes. But modern ITs aim to make this interaction feel as natural and engaging as possible. So they often leverage things like conversational AI.
Like chatbots, talking to the tutor.
Exactly. Using natural language processing so you can type questions or responses in a more conversational way, and the AI can understand and respond similarly. Some might even use voice interfaces.
Talking to your math tutor bot.
They might also use interactive simulations, where you can manipulate variables and see results, gamified elements like points or badges to keep things engaging, or adaptive visual dashboards that clearly show your progress and areas you need to work on.
So making it feel less like a dry program and more like, an interaction.
That's the goal, to create an experience that's intuitive, engaging, and ideally feels like you're having a productive dialogue with a helpful patient mentor.
Okay, that paints a clear picture of the 4 main parts: domain, student, pedagogical, and UI. Now that we understand the anatomy, let's move to question 6. What are the key capabilities that these modern intelligent tutoring systems offer to a student? What can they actually do?
So when those 4 components work together effectively, they enable some really powerful capabilities for learners. The source highlights several key ones. The most obvious, perhaps, is 24/7 availability.
The always-on mentor idea again.
Exactly. You get stuck on a math problem at 10 p.m. on a Sunday. The ITS is there. Want to review biology concepts before school starts? It's ready. Learning support isn't tied to school hours or a human tutor's schedule. It's on demand. Anytime, anywhere, you have a connection.
That flexibility is huge, especially for busy students or self-learners.
Absolutely. Another major capability is the interactive, step-by-step guidance. This is a big differentiator from just getting the final answer checked.
How so?
An ITS can walk you through a complex problem step by step. If you make a mistake on step 2, it can give you feedback right then, helping you correct that specific part of the process before you move on.
So it ensures you understand the method, not just whether the final number is right.
Precisely. It focuses on the reasoning process. This is much closer to how a human tutor would work through a problem with you, intervening at the point of error. Simple apps usually just mark the whole thing wrong at the end.
That makes sense. What else?
Then there's the adaptive problem selection we touched on. Because the student model is constantly assessing you, the system can continuously adjust the difficulty and type of problems it presents.
Keeping you challenged but not overwhelmed.
Exactly. It tries to keep you in that zone of proximal development where learning is most efficient. It avoids wasting time on things you've already mastered and avoids the frustration of problems that are currently way too hard. The goal is productive challenge.
Okay, that sounds really efficient.
And related to that personalization is the capability for multimodal explanations.
Meaning it can explain things in different ways.
Yes. Recognizing that different people learn differently, and IT can explain a concept using various formats. If a text explanation isn't clicking for you, it might offer a diagram, an animated video, or maybe an interactive simulation where you can experiment with the idea yourself.
Catering to diverse learning styles automatically.
That's the aim. It increases the chances that the explanation will resonate and lead to real understanding.
These capabilities sound really impressive. Let's go back to the human tutoring comparison. Question 7. A big part of why one-on-one tutoring works is that it often feels like a safe, personal space. Can an ITS offer any benefits in that regard?
That's a great question. While an AI can't replicate the human relationship, the source points out a significant benefit in terms of creating a safe learning environment. Immediate, non-judgmental feedback.
Non-judgmental, because it's a machine.
Pretty much. The feedback is instant, which we know helps learning. You immediately see the consequence of your action or thought.
Yeah.
But crucially, it's delivered privately by a system that doesn't get impatient, doesn't sigh, doesn't make you feel embarrassed in front of peers.
Right. There's no social risk in making a mistake or asking a dumb question.
Exactly. For many students, especially those who are anxious or perhaps less confident, this can dramatically lower the fear of failure. It creates a psychologically safe space where they feel more comfortable trying things out, making mistakes, and learning from them without feeling judged.
That could really encourage persistence, couldn't it? Making students more willing to tackle challenging stuff.
That's the idea. Reducing that anxiety barrier can be a really powerful factor in helping students stick with difficult topics.
Okay, that's a really interesting benefit. Now, thinking bigger picture, question 8, the source talks about democratizing support. What are the key benefits for students if these AI tutors become widely available? What's the potential societal impact?
This is where the vision gets really exciting and potentially transformative. The biggest promise, highlighted in the source, is democratized access to high-quality learning support.
Meaning bringing that personalized one-on-one style help to everyone.
That's the dream. Imagine if every student, regardless of their family's income, their school's resources, or their geographic location, could have access to this kind of patient, adaptive, step-by-step guidance whenever they needed it.
That would be a massive equalizer.
It really could be. The source specifically mentions the potential impact in countries like Canada, reaching students in remote areas, northern communities, or other underserved regions where access to specialized tutors or even consistent supplemental instruction can be really limited. IASYS could bridge that gap.
Providing a baseline of high-quality support everywhere.
Exactly. Another major benefit enabled by this widespread access is supporting mastery-based learning.
What does that mean in this context?
It means students can work through material at their own individual pace. With an ISS, you're not forced to move on with the rest of the class if you haven't quite grasped a concept yet. You can keep practicing, getting explanations, working on a topic until you achieve true mastery.
So you build a really solid foundation before moving to the next thing.
Yes. This is huge for preventing those cumulative learning gaps that often happen in traditional classrooms, where a student falls behind on one topic and then struggles even more with the next one that builds on it. IS allows for that consolidation of knowledge.
Ensuring no one gets left behind just because the pace was wrong for them.
Right. And all of this, the safe environment, the personalized pace, the on-demand support, often leads to a third benefit: increased confidence in agency.
How so?
When students feel safe to fail and learn from mistakes, when they can get help exactly when they need it, and when they feel they can truly master challenging subjects at their own speed, it tends to significantly boost their academic confidence.
They start to feel like, I can do this.
Exactly. And it gives them more control, more agency over their learning journey. They're not just passive recipients of instruction. They're actively engaging with the material with a supportive tool. This can foster a greater sense of ownership and independence in their learning.
Those are some really compelling potential benefits for students. But what about the other side of the classroom? Question 9. How do these systems benefit educators? And let's address the elephant in the room. Are they meant to replace teachers?
Yeah, that's a critical question, and the source is very clear and emphatic on this point. IAS are not meant to replace human teachers. Full stop.
Okay, that's reassuring to hear stated plainly.
Definitely. Instead, the vision is for IDAS to function as powerful assistants for educators.
Assistants? In what way? How do they help a teacher manage a classroom of, say, 30 kids?
Think about all the time teachers spend on certain tasks. IDAS can take over a significant portion of the load related to foundational instruction, providing personalized skills practice, offering homework support, and giving that immediate feedback on basic concepts for every single student.
So handling some of the more routine, individualized practice elements.
Precisely. Automating some of that allows teachers to redirect their limited and valuable time. This frees them up to focus on higher-order skills and activities where their human expertise is truly indispensable.
Like what kind of activities?
Things AI just can't do well, or at all. Facilitating complex, collaborative projects among students. Leading nuanced, Socratic discussions that go beyond scripted answers. Nurturing creativity and critical thinking in open-ended ways. Providing mentorship and targeted social-emotional support based on understanding the whole child.
So AI handles the personalized drill and practice. Teachers handle the deeper learning, collaboration, and human connection.
That's the ideal partnership model. And there's another major benefit for teachers. IAS provide rich diagnostic data.
Right, all that information the student model collects.
Exactly. The system can generate detailed analytics dashboards for the teacher, showing not just individual student progress, but also highlighting common misconceptions or areas where the entire class might be struggling.
Ah, so the teacher gets a much clearer picture of what's going on under the surface.
Yes. Instead of just seeing grades on a test, they can see why students might be struggling with specific concepts. This allows them to plan much more effective and targeted interventions in the classroom. They know exactly who needs help and specifically what they need help with. It makes their time much more impactful.
So it's a tool to empower teachers, giving them insights and freeing up time rather than replacing them.
That's absolutely the vision presented.
Okay, this sounds incredibly promising, almost like a sci-fi vision of education becoming reality. But as always, there must be bumps in the road. Question 10. This technology sounds great, but it must have significant challenges. What are some of the main hurdles in developing and deploying IDES effectively?
Oh, absolutely. The source makes it clear that realizing this potential isn't easy. There are some major hurdles. First and foremost is the sheer developmental complexity.
It's hard to build these things.
Incredibly hard. Building an IDES with those sophisticated, interconnected AI models, the domain, student, and pedagogical models that are accurate, robust, and genuinely effective is a massive undertaking. It's extremely resource-intensive.
Needs a lot of time, money, and brainpower.
Yes, and crucially, it requires deep expertise not just in cutting-edge AI, but just as importantly, in educational theory, learning sciences, and specific subject matter pedagogy. You need people who understand how people learn just as much as you need AI experts. Getting that interdisciplinary mix right is tough.
It's not just a tech problem, it's an education problem too.
Exactly. And that leads directly to another major challenge, ensuring pedagogical quality.
Making sure the AI actually teaches well.
Right. The ultimate effectiveness of the ITS completely depends on the quality of the teaching strategies programmed into that pedagogical model. If that model is based on flawed educational theories, or if it's implemented poorly, the system could actually be ineffective.
Worse.
Or potentially worse, it could end up teaching students inefficient methods, reinforcing misconceptions, or failing to address deeper understanding. The risk of having a poorly designed AI tutor is significant. Getting the teaching brain right is absolutely critical and very difficult.
Quality control is paramount then. That makes sense. Now, thinking about the tutoring process itself. Question 11. What about the limitations of AI in terms of the human side of tutoring? What can't it replicate?
This is a really important point the source touches upon. Despite advances in effective computing, AI currently has significant emotional and social blind spots.
It can't do empathy.
Not genuine empathy, no. It can't replicate the authentic encouragement, the personal relationship, the motivational insight that comes from a great human teacher or tutor who truly connects with the student. Humans understand a student's broader life context in a way AI doesn't.
Like knowing if a student is having a bad day because of things outside of school?
Precisely. Family issues, social dynamics, personal struggles. A human teacher can often sense these things and respond with genuine care and understanding, adapting their approach accordingly. That deep human connection itself is a vital part of learning, motivation, and well-being, and it's something current AI simply cannot provide.
It can simulate tutoring strategies, but not the human relationship.
That's a good way to put it. That human element remains irreplaceable.
Okay. And beyond the technical and pedagogical challenges, what about ethics? Question 12. What are the key ethical concerns we need to be really aware of as ITS become more widespread?
This is hugely important, and the source highlights several critical ethical considerations. First up is data privacy and security.
We touched on this with the student model collecting all that data.
Exactly. These systems, by their very nature, collect incredibly detailed, fine-grained data on how a student learns every interaction, every mistake, their inferred emotional states, their learning pace, their specific weaknesses. This is highly sensitive personal information.
And potentially very valuable, or very risky if it gets out.
Absolutely. So ensuring this data is collected, stored, and used ethically, transparently, and in strict accordance with privacy laws like GDPR, PIPEDA, or student data privacy regulations is non-negotiable. Protecting student data has to be a top priority.
Robust security and clear policies are essential. What else?
Another major concern is bias and equity. There's a significant risk if the AI models, particularly the student and pedagogical models, are trained predominantly on data from a narrow demographic group.
How could that cause problems?
Well, the system might end up being optimized for that specific group and could be less effective or even biased against students from different cultural backgrounds, linguistic backgrounds, socioeconomic statuses, or neurodiverse learners.
So the personalized tutoring might not be truly personalized or fair for everyone.
Exactly. It could inadvertently perpetuate or even worsen existing educational inequalities. It's absolutely critical that these systems are designed, trained, and rigorously tested for fairness, bias, and equity across diverse student populations.
Building equity in from the start.
It has to be a core design principle. And a third ethical consideration the source mentions is the risk of over-reliance.
Becoming too dependent on the AI tutor.
Potentially, yes. There's a concern that if students get too used to the constant step-by-step guidance and immediate feedback for everything, they might not develop crucial skills like resilience in the face of ambiguity, independent problem-solving abilities, or the willingness to struggle and figure things out on their own without prompts.
Like needing the GPS for every journey, as you said earlier. It might stop you from learning the route yourself.
It's that kind of concern. We need to ensure ITs are used in a way that scaffolds learning effectively, but also fosters independence and the ability to tackle problems autonomously when the scaffolding is removed. Finding that balance is key.
Privacy, bias, over-reliance. Definitely critical things to keep in mind. Okay, let's wrap this up with the final question, number 13. Considering all this, the incredible potential, the significant challenges, the ethical tightropes, what is the overall vision for intelligent tutoring systems in the future of education, according to the source?
The source concludes by painting ITIS as a really remarkable step forward, a step towards achieving that long-sought-after ideal of providing personalized, adaptive, one-on-one style academic support for every single learner.
Making that gold standard finally scalable and accessible.
That's the core vision. They're positioned not as a magic bullet, but as a potentially key pillar in the ongoing transformation of education. The promise is immense. Democratizing access to quality support, enabling true mastery-based learning at an individual pace, and, as we discussed, freeing up human educators to focus on those complex, creative, and deeply human aspects of teaching.
The potential impact, especially in places with geographical or resource challenges like parts of Canada, as the source noted, seems particularly powerful.
It really does, but, and this is a crucial but, the source strongly emphasizes that realizing this promise requires a very thoughtful and cautious approach.
Not just rushing ahead with the technology.
Absolutely not. We must proactively address those significant challenges we talked about, the developmental complexity, ensuring high pedagogical quality, rigorously safeguarding data privacy, and actively designing for equity and fairness to avoid bias.
And remembering their limitations.
And always remembering their limitations. The ultimate goal, reiterated clearly, is not replacement. It's about creating powerful, always-on mentors and assistants that work synergistically in partnership with human teachers.
Augmenting human intelligence and connection, not supplanting it.
That's the critical takeaway from the source. The vision is to strategically leverage AI to provide scalable, personalized support in order to empower both students and teachers, ultimately fostering a more effective, equitable, and engaging learning ecosystem for everyone involved.
Powerful vision indeed. That was an incredibly thorough deep dive into intelligent tutoring systems. We've gone from the basic concept through the AI anatomy, the capabilities, the benefits for students and teachers, and importantly, the significant challenges and ethical considerations.
It really covers a lot of ground. These systems are definitely more than just fancy apps.
Absolutely. They represent a serious attempt to use AI to personalize learning support at scale. So, as these AI tutors become more sophisticated, maybe even better at sensing our confusion or frustration, here's a final thought for you, our listeners, to mull over.
Okay.
How do we ensure that this incredibly powerful, personalized, always available assistance genuinely enhances a student's ability to think independently, to grapple with complex problems without immediate answers, and deepens rather than diminishes their connection with the invaluable human element, their teachers and peers?
That's the tightrope we need to walk, finding that optimal blend.
It certainly is. A huge thank you for joining us for this exploration today. If this conversation sparked your interest, please subscribe to our channel, Tech AI and Beyond. We'll keep diving deep into how technology is shaping our world.